Hi, I'm Alex.
I'm Raquel.
And I'm Hannah.
Did you know that gases are all around us? Gas is the third state of matter.
And all different kinds of gases are in the air all around us. Gas is essential to sustaining life on this planet.
There's oxygen, carbon dioxide, nitrogen, and even small amounts of methane, argon, and hydrogen in the Earth's atmosphere.
Without gases, we wouldn't be alive.
All gases exert pressure and have a volume and temperature. Laws were discovered by famous scientists to explain the behavior of gases.
Pressure is the amount of force exerted by gas particles per unit of area.
Pressure is inversely related to volume. That is, as pressure goes up, volume goes down, and vice versa.
A 17th century scientist named Robert Boyle discovered this relationship between pressure and volume and created this law to illustrate his discovery.
He proved the inverse relationship between pressure, the amount of force exerted by gas particles per unit of area, and volume by conducting experiments.
We will demonstrate Boyle's law using a bell jar and a bag of chips.
How are we going to do that?
Here, we'll show you.
Here we have a regular bag of chips,
A bell jar.
And a vacuum. So what we did was place the chips under the bell jar, made sure it was airtight, and now we're going to use the vacuum to remove as much air as possible from the jar.
Demonstrate, Alex.
Alright, here we go. By turning this valve, we are removing the air particles from this bell jar.
Why did that happen?
Well, when we remove the air from the jar, we are decreasing the pressure in the bell jar. This is because we are moving the gas particles, and since the pressure is defined as the force exerted by gas particles per unit of area, the less particles of gas we have, the lower the pressure.
Okay, I understand that. But why did the bag of chips explode?
Well, like Boyle said, as pressure decreases, volume increases. Since the pressure in the bell jar went down, the volume of the bag of chips went up, making it pop.
Well, Robert Boyle was a pretty smart guy, but there are so many other factors in the environment that seem like they would affect gases.
You're right, Raquel, and other scientists figured this out.
For example, Gay-Lussac theorized that the temperature and pressure of gases are related.
He discovered a law that showed that this relationship is a direct one. As temperature goes up, so does pressure.
And remember, pressure is the force exerted by gas particles per unit area, and temperature is the average kinetic energy of the gas particles.
We'll show you how this works.
For this demo, you'll need a peeled hard-boiled egg and a bottle that has a wide enough mouth to allow the egg to go in, but only with some pressure. We used a 13.7 fluid ounce Starbucks Frappuccino bottle.
First, soak a piece of paper towel in alcohol to make it extra flammable.
And then light it on fire.
Once the paper is on fire, put it in the bottom of the bottle using tongs.
Then quickly place the egg on top of the bottle.
As you can see, the egg will be sucked into the bottle.
This is Gay-Lussac's law in action.
When the egg is placed on top of the bottle, the match goes out and the temperature goes down. This causes the pressure to also decrease. The egg is forced to go in because the pressure outside is higher than the pressure inside the bottle.
Hey, can I have my egg back, guys? I'm pretty hungry.
Okay, so Jacques Charles was another famous scientist who experimented with gases and their properties.
He came up with a law that shows as temperature increases, volume decreases, and the other way around.
There must be a good way to observe that.
Here, we have a balloon.
And some dry ice.
But first, we need safety goggles. The ice is around negative 78 degrees Celsius or 195 Kelvin.
We had another balloon exactly the same size as this one, and we covered it in some dry ice just a few hours ago.
Let's take a look and see what happened.
Whoa, it's so small. What happened?
Well, as Charles' law said, as temperature decreases, so does volume. We see this in this demo.
The dry ice made the temperature of the gas inside the balloon decrease, so the volume of the balloon decreased as well.
All these laws are useful by themselves, but when they're together, they're so much more helpful.
This is why the combined gas law was created.
By putting together Boyle's, Gay-Lussac's, and Charles's law, we can observe the relationship between all three characteristics of gases: temperature, pressure, and volume.
Scientists use the combined gas law to do so many calculations.
A gas has an initial volume of 30 liters at a pressure of 110 kilopascals and a temperature of 420 Kelvin. Find the final temperature of the gas, which has a volume of 40 liters at a pressure of 120 kilopascals.
We can determine the final temperature by rearranging the equation.
The final temperature equals initial temperature and final pressure and volume divided by initial pressure and volume.
We can plug in the values given into a calculator and find that the final temperature is 610 Kelvin.
To summarize, pressure and volume are inversely related and pressure and temperature are directly related as well as volume and temperature. When you combine all of these relationships, you get the combined gas law.
You are now all experts in gas laws.